right, continuing with our big idea for probability. Knowing about the probability helps us to compare events and to solve problems and understand the real world. Today we're moving from theoretical probability to demonstrating an understanding of experimental probability. Once we actually do the flipping of the coin or the rolling of the die, how does that actually compare to what we should have gotten in theory, the theoretical probability? You will be conducting probability experiments and explaining the results using the predictions and making predictions based on, in theory, the theoretical probability, what should have happened. This is lesson 7. All right, taking a look at the Connect section, we have Jenny and Morningstar, who put colored cubes into a bag. They used 4 blue cubes, 2 red cubes, 2 green cubes, and 2 yellow cubes. A cube is picked from the bag at random, so without looking. The theoretical probability of a blue cube is 4 out of 10, because there are 10 altogether. If you wanted to, you could make that an equivalent fraction, or make it 2 out, which would make it 2 out of 5. So she has a 2 out of 5 or a 4 out of 10 chance. If she did 10 picks, she should have ended up with blue 4 times. If she did 5 picks, she should end up with blue 2 times. Jenny and Morningstar plan an experiment for their class. Each student would pick a cube from the bag without looking, then replace it and pick another one. So important to put that cube back in so it doesn't make our possible outcomes fewer each time. She would do this 10 times. All right, so she would do this 10 times. Here are the results of our experiment. So blue was actually chosen 6 times. Red was actually only once. Green was only once. And yellow was twice. So sometimes, and actually often, our theoretical probability and our experimental probability don't quite match, but they are usually close. So often our theoretical probability is close to what actually happens, even though it's not quite what actually happens. So in theory, we should have picked blue 4 times. Well, we got blue 6 times. Pretty close. In theory, we should have picked red 2 times. Well, we got 1 red. That's pretty close. In theory, we should have picked green 2 times. We also got green once, so that was pretty close. In theory, we should have picked yellow twice. We did get yellow twice. So our theoretical probability compared to our experimental probability isn't necessarily always the same, but it's often a good predictor as to what's going to happen. To communicate our experimental probability, it's much like our theoretical probability, except we have the number of times the outcome occurred. So our blue, we got it 6 times, over the number of times the outcome was conducted, or the experiment was conducted. Well, how many picks did they have? Well, they had 10 picks, so that becomes our bottom number, 6 over 10. And again, it could be an equivalent fraction, 3 over 5, is our experimental probability. So it's different from theoretical. It's still a fraction, but it's different in that this is the number of times we got it. This is the number of times we tried to get it. All right, so here they've taken everybody's and they've combined them, the results from 10 experiments. So now they have 100 possible outcomes, possible experiments. That's the number of times they've tried it. They've done it 100 times. So out of the 100 times, they got blue 43 times, red 22 times, green 18 times, and yellow 7 times. So the blue cube was picked 43 times. Our experimental probability now becomes 43 out of 100. We picked blue 43 times. How many trials did they do? Well, they did 100. So 43 out of 100, which is pretty close to our theoretical probability of 4 out of 10 if we make it an equivalent fraction. Remember multiplying to get it out of 100 on the bottom as well, so we can properly compare. Always better to compare as best you can, as closely as possible. So both out of 100. What we do to the bottom, we do to the top. So 4 times 10 is 40. So we should have gotten blue 40 times out of the 100. We got it 43 times out of the 100. And we can do the same thing with the red. Red was supposed to be 2 out of 10, so 20 out of 100. We got it 22 out of 100. That's pretty close. Same thing with the green and the yellow. They should all have been about 20 out of 100. And all of these numbers are pretty close to 20. So our theoretical probability helps to predict what's happening in the experiment. The experiment probability might not be exactly the same, but it should be fairly close. Remember, an experimental probability is also a fraction comparing the number of times a specific outcome happened to the number of trials. So the number of times we had that outcome, so blue, for example, to the number of times we tried it, which was, in this case, 100 times, and 43 times is what we got blue. So that would make that our experimental probability. All right, now it's time for you to practice. Here we have a coin flipping experiment. Here's the results. You're going to try to determine the experimental probability for flipping heads. Compare the theoretical and experimental probability, and how come they can be different. Take a moment, press pause, and try answering these questions using this results. All right, let's take a look. Experimental probability of flipping for heads. Well, how many trials did they have? Well, they had 10, so that becomes our bottom number for the experimental. How many heads did they have? 1, 2, 3, 4. So 4 out of 10 was our experimental probability for flipping heads. In theory, we know if we flip the coin 10 times, there's half of them as heads, 1 out of 2. 1 heads out of 2 possible heads or tails. So we should have gotten half of the time a heads. So it should have been 5 out of 10. Why can those two be different? Why can it be 4/10 compared to 5/10? Well, in theory, what should happen doesn't always exactly happen, right? The experiment might end up with a slightly different answer. But remember that the theoretical probability can help you determine if your experiment was, first of all, conducted properly. So, for example, if I landed on heads 9 times out of those 10, probably there was something wrong with how I conducted my experiment. Maybe I have a trick coin that's weighted heavier on the head side. And so the experiment wasn't quite done properly. If you get a very odd number in your experiment compared to, in theory, what should have happened, probably there's something that hasn't quite been done correctly. All right, you're going to continue with your practice. Using this information, try to answer the questions. Press pause and try now. All right, let's take a quick look. Reese conducted an experiment. She put red and blue cubes into a bag. She chose one cube, recorded the color, returned the cube to the bag. This is the results she has. How many trials did she conduct? Well, she got red 14 times and 6 blue times, So altogether, she conducted 20 trials. What was the experimental probability of red? Well, 14 out of 20. What was the experimental probability of blue? Well, 6 times it was chosen out of 20. What does this tell us? Well, probably she has more red items in her bag than she has blue items. Based on our results here, it looks like she probably even has 2/3 more red as she does blue. Right, now you are on to your practice. You are determining the experimental probability, and then you're comparing that results to the theoretical probability. Page 278, 279, numbers 1, 2, 4, and 5. Remember to do the questions fully. Ask any questions if you have any as you go.